Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Dear students, Assalamu alaikum. Today we will look over the distribution systems and their connection schemes. Connection schemes means their architecture, in which configuration different distribution systems are connected with the consumers. The very first one is the radial system. We will discuss it. It in at length, and then there is the ring main distribution system, and final one is the interconnector system. In radial system type architecture, substation and the feeder are connected radially. It means that only connections are taken away from the substation, and then the feeder is loaded at different distribution points. As in this point, A is connected with a distributor, and then service mains are shown also. Similarly, there may be other points on this feeder, but all these are radially connected with each other, or we can say that it is a star topology. In the system, radial system, in the system, separate feeders radiate from a single substation and feed the distributors at only one end only. Drawback of this architecture is the end of the distributor near to the feeding point will be heavily loaded. So the end of the distributor near to the feeding point, this is the feeding point. If there are, let's say, 10 branches onwards, or 10 different distributors, then each will be loaded and this point, which originates from the substation, will be heavily loaded. The consumers are dependent on a single feeder and the single distributor, and they have no other reliable source of energy. So whenever there is a fault in the feeder, let's say a fault comes here, then the whole of the consumers connected with this feeder and the distributor will go offline, and they will receive no electricity supply. The third drawback of this architecture is the consumers at the distant end of the distributor would be subject to serious voltage fluctuations when the load on the distributor changes. For example, if a consumer is at this end, that is the far end of the distributor, there are so many other distributors also which have not been shown in this diagram. So if a consumer at the far end, if there is a load, if the load changes in the feeder or distributor, then the consumer at the tail or end will get most fluctuations. This is the case we usually see in our villages when the tail end users of the electricity have normally very low voltage, because the length of the feeder and the distributor make it heavily losses, and the voltage is very low at the far end. Additionally, the variation in the loads cause the fluctuation, and these fluctuations are reflected on the end, on the consumers at the end. The ring main system has a certain advantages over the radial system, and it can be described as under. In this system, the primaries of the distribution transformers form a loop. The loop circuit starts from the substation bus bars makes a loop through the area to be served and returns to the substation. As shown in this diagram 12.9, here is a substation that is feeding this overall locality. It is said that the primaries of the distribution transformer, these are the three distribution transformers as you see, their primaries, basically this is the feeder which starts from the substation from point S, then it goes to L, N, O, P, Q, R, and returns back to the same position S, making it a ring. And these primaries are interconnected with each other. Secondaries of these distribution transformers are connected with distributors, and then they are connected with the consumer loads. In this case, this system has the less we have certain advantages. There are less voltage fluctuations at the consumer terminals in this case, and also in case if there is a short circuit or there is a failure in the feeder circuit, let's say at this point F the circuit fails or it disconnects or it gets breaks, then still we have connectivity with these transformers through S, R, Q, P, O and M. Although the S and SLM circuit has gone out of circuit, yet we have electricity available. The only vulnerable point in this case is this point S and the substation. In case there is a problem in this area, then the whole ring will go out. However, this is shown in this just diagram, but actually this point lies actually at the substation, and there is and ring starts from the substation and then terminates on the substation itself. As the system is very reliable, as each distributor is fed via two feeders. In this case, in case of as I have already said, that in case of failure in the feeder, the distribution transformers are fed. The third one architecture that comes in the distribution system is known as the interconnected systems. It is interconnected systems because there are a number of substations feeding the circuit. Here here the ring structure is used as it is in the previous case. However, the ring is fed by two substations, namely S1 and S2. Rest of the configurations are almost same. Interconnected systems: when the feeder ring is energized by two or more than two generating stations or substations, it is called interconnected system, as shown in this diagram. Figure 12.10 shows the single line diagram of the interconnected system where the closed feeder ring ABCD, A, B, C and D, this is a closed feeder ring, is supplied by two substations S1 and then S2. Advantages: it increases the service reliability. Service reliability in the sense, in case if the ring is disconnected at some point, then the distribution transformer are still connected via other alternate route to the distribution transformer. Any area fed from the one generating station during the peak load hours can be fed from the other. So in case if a substation goes out of service due to any emergency or due to some reason, then the still other source S2 will be available and electricity can be supplied to the area or locality. This reduces the reserve power capacity and increases the efficiency of the system. This is all from my side today. Thank you.